In this video, I'm going to go over how to graph a quadratic when given intercept form. So the neat thing about intercept form is that it shows us the x-intercepts. So this is our intercept form right here. I want to point out that we notice that we have a negative a value. So that means our quadratic will point down. And then we have our two factors. And these two factors are going to tell us what our intercepts are. You can look right there and see it says x plus 3. Well, we think opposite, and so that means that the first x-intercept will be at negative 3. In the second one, it's x plus 5, so the second x-intercept will be at negative 5. So I'm going to come over here and write those down as our x-intercepts. Remember, we always write these as ordered pairs, so negative 3 comma 0 and negative 5 comma 0. After we have our x-intercepts, we can find the axis of symmetry. This is found by simply adding the x-intercepts and dividing by 2. So I'm going to add negative 3 plus negative 5 divided by 2. Negative 3 plus negative 5 is negative 8. Divided by 2 is negative 4. So our axis of symmetry is that x equals negative 4. The next thing we need to do is find the vertex. Well, remember the vertex's x coordinate is the same as the value at the axis of symmetry. So we already know that that is negative 4. Now we can plug negative 4 into the equation to find y. So we're going to do f of negative 4. Bring down that negative, and we've got negative 4 plus 3 times negative 4 plus 5. To simplify this, don't forget about that negative. Negative 4 plus 3 is negative 1. Negative 4 plus 5 is positive 1. Negative 1 times positive 1 is negative 1. And then a negative 1 is positive 1. So the y value we get is positive 1. And there's our vertex. Using these three things, the axis of symmetry, vertex, and x-intercepts, we have enough to plot our graph. So let's go ahead and do that now. I'm going to start, 2, 3, 4. I'm going to start with the axis of symmetry. Then I'm going to plot the vertex at negative 4, 1. And then I'll plot the x-intercepts at negative 5, 0 and negative 3, 0. Now you could choose to find one more point if you would like, but right now that's enough points that I can draw the graph. Now let's go over some of the characteristics. The first one, domain. Remember, domain is x values, and this one is actually the same for all quadratics when we're not talking about word problems. And that is from negative infinity to infinity. The reason is because this graph goes left and right forever and ever. Now for range, range is the y value, so we look low to high. Does this graph go down forever? Yes, it does. So the range starts at negative infinity. But does it go up forever? No, it stops right here, right at the vertex. The value of the vertex is a positive 1 on the y-axis. So the highest value that our range reaches, because it's y values, is 1. And we write that with a bracket because 1 is a point on the graph. The next characteristic is a maximum or a minimum point. Well, we see right here that same point that was the highest point for our range, that is the highest point for the graph. So that is a maximum point. And that point is a special point. It happens to be the vertex. So it's at negative 4, 1. All right, the next thing that we're going to do is the interval of increase or decrease. Now, these intervals of increase or decrease, they always change or get broken up at the vertex. So think the vertex is where we're going to break between an increase and a decrease interval. And remember, you imagine yourself on the very left of the graph going on the roller coaster ride. And as you start the ride, you are increasing, 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 increasing. And then once you get to the vertex, you turn and you start decreasing, 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 decreasing. So the first increasing interval, it is the whole left side of the graph. Well, the furthest left that our graph will ever reach for the x values is negative infinity, because remember the graph goes on forever and ever. So my interval of increase actually begins at negative infinity because it begins all the way to the left. And then we're increasing, 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 increasing until we get to the vertex. The vertex is at x equals -4. So the interval of increase ends at -4. Of course, once we're done increasing, it's time to start decreasing. So the interval of decrease starts exactly where the interval of increase stopped at -4. And then it continues to decrease forever and ever and ever and ever and ever as I keep going to the right. So it is decreasing all the way until positive infinity. And I know that that can be confusing, but remember it's because we're moving to the right. I know it's going down. We said it's decreasing, but our interval is the x values. All right, let me erase this and then let's talk about the positive and negative intervals. So positive and negative intervals, these ones are broken up by the x-intercepts, because the positive intervals are where y's are positive, which happens above the x-axis. And the negative intervals, that is where the y values are negative, and that happens below the x-axis. So the x-intercepts break up these intervals. So our positive interval here starts at this first x-intercept at -5, and it stays positive until we get to the other x-intercept at -3. So it's from -5 to -3. Now, the negative intervals, we've got two of them. The first one on this side here, it is negative all the way from the very beginning of the graph. Remember the graph, x values begin at negative infinity. And then it is negative, negative, negative until you get to that first x-intercept at -5. But we have a second negative interval, and that one starts at -3, and then it's negative for the rest of the graph as we continue to the right towards positive infinity. All right, last two, I need to find the y-intercept. Well, the y-intercept is not one of the points that we happen to graph already. So in order to find it, I'm going to need to do it by solving the equation. To find the y-intercept, we just plug in 0 for x. So I'm going to plug in 0 plus 3, 0 plus 5. I also brought down that negative. And now I'll simplify. So we've got negative, 0 plus 3 is 3. 0 plus 5 is 5. Now I'll multiply. 3 times 5 is 15. Bring down the negative. So we get -15. Our y-intercept is at 0, -15. And the very last thing I need to do is end behavior. As x approaches infinity, remember that's the right side of the graph. And then as x approaches negative infinity, that's the left side. And we need to figure out what is f of x doing on both of the ends of our graph. On the right side of the graph, our end is pointing down. So that's down towards negative infinity. On the left side of our graph, as we go towards negative infinity for the x's, y is also again going down towards negative infinity. And so there is the end behavior.